Breaking news. At 02:19 UTC this morning, observatories on 3 continents simultaneously registered something that should not exist. A fresh data stream from the James Webb Space Telescope, cross-verified seconds later by the Atacama Large Millimeter Array in Chile and the European Space Network's Deep Space Antenna in Spain, revealed a spectral anomaly in the interstellar object known as 3I Atlas. Moments ago, astronomers watching live feeds saw a clean, well-defined spectral line suddenly drift, then split, then recombine, all within a span of less than 90 seconds. Today, the impossible just happened. This was not noise, this was not instrument error, this was a controlled, measurable shift in emitted energy, and if confirmed, it changes everything we thought we knew about how objects behave in interstellar space. If you want more real-time cosmic updates as this story unfolds, make sure to like this video and subscribe, because what we are about to show you may redefine physics itself. Within minutes of the alert, internal channels at NASA and ESA lit up. Automated anomaly flags, rarely triggered, were activated across multiple observatories. I remember staring at the incoming data feed, watching the spectral graph redraw itself in real time. The line was there, unmistakable, hovering in a narrow infrared band around 4.3 microns. Then it moved. Not gradually, not chaotically, but with a precision that defied every natural model we have. Before we dive into what this could mean, we need to establish why this detection carries such extraordinary weight. This observation was not made by a single telescope under uncertain conditions. It was captured by a coordinated network of humanity's most advanced instruments. NASA's James Webb Space Telescope, operating from the Sun-Earth L2 point nearly 1.5 million kilometers from Earth, provided the initial high-resolution infrared spectra. Within seconds, the Atacama Array in northern Chile, perched 5,000 meters above sea level, confirmed anomalous millimeter wave emissions. 11 minutes later, optical and ultraviolet follow-ups from the Hubble Space Telescope aligned with the same coordinates. Data packets flowed through Caltech's Jet Propulsion Laboratory, Harvard's Smithsonian Center for Astrophysics, and ESA's Operations Center in Darmstadt, Germany. Independent teams on 3 continents reached the same conclusion. The spectral line associated with 3I Atlas was unstable and shifting in a way no comet, asteroid, or known interstellar body ever has. To understand why that matters, we need to rewind the clock. 48 hours before this event, 3I Atlas was considered, if not ordinary, then at least predictable by interstellar standards. Discovered earlier on a hyperbolic trajectory, it was already famous for its unusual acceleration and its apparent loss of mass without a visible coma. But in the 2 days leading up to today, its spectral signature remained stable. Its dominant emission lines, associated with carbon compounds and trace metals, sat exactly where models predicted, within fractions of a nanometer. At T-36 hours, orbital calculations placed it at approximately 2.17 astronomical units from the Sun, moving at 42.6 kilometers per second relative to the solar barycenter. Nothing in those numbers suggested imminent upheaval. Then, 11 hours before the detection, something subtle began to change. At 15:03 UTC yesterday, a routine spectroscopic sweep by the European Southern Observatory flagged a slight asymmetry in one infrared line. The deviation was small, less than 0.02%, but it was logged. 6 hours later, the deviation had doubled. Automated systems still categorized it as low priority, possibly thermal variation due to solar radiation. But at 3:41 UTC, less than an hour before the main event, the asymmetry sharpened into a clear drift. The line shifted by nearly 0.6 nanometers towards shorter wavelengths, implying an energy increase that could not be explained by heating alone. At 02:19 UTC, the drift accelerated. In under 90 seconds, the spectral line split into 2 distinct components, separated by a precise interval corresponding to an energy difference of approximately 1.7 electron volts.
Both components remained perfectly narrow, no broadening, no turbulence. Then, just as suddenly, they merged back into a single line, now offset from its original position. The total emitted power remained constant within measurement error. Energy was not added or lost, it was redistributed. No natural process we know of can do this. Comets outgas chaotically, asteroids fracture or tumble. Even exotic objects like magnetars and pulsars follow statistical patterns shaped by extreme gravity and rotation. But what we saw from 3I Atlas was controlled, precise, deliberate. The spectral line behaved less like a natural emission and more like a tuned signal. Within minutes, emergency observation protocols were activated. JWST shifted to continuous monitoring mode, locking its instruments onto the object. Hubble adjusted its orientation to capture simultaneous optical spectra. Radio telescopes in Australia and South Africa joined the network, scanning for correlated emissions. What they found deepened the mystery.
Spectral shift, a low-intensity radio pulse was detected at 1.42 gigahertz, the hydrogen line frequency. But this pulse was not broad or noisy. It was narrowband, repeating every 73 seconds. 73 seconds is not a meaningful number in astrophysics. It is not tied to orbital periods, rotational dynamics, or plasma oscillations, but it is a prime number. At this point, the investigation split into two camps. Dr. Elena Voss, a spectroscopist at Caltech, led the mainstream analysis. Her team proposed that 3I Atlas might contain an unusual crystalline structure, possibly formed in an environment with extreme radiation pressure. In this model, internal phase transitions could cause abrupt changes in emission lines without catastrophic disruption. Simulations showed that under very specific conditions, temperatures exceeding 1200 Kelvin and internal stresses aligned along a single axis, spectral shifts could occur. But even these models failed to reproduce the observed precision. The line splitting was too clean, the timing too exact. On the other side was a smaller, quieter group of researchers asking a different question. What if the spectral instability was not a byproduct of stress, but a function of control? Dr. Marcus Hale, working with a classified research unit affiliated with ESA, ran computational models treating 3I Atlas not as a passive body, but as an active system. In these simulations, the spectral line behaved like a diagnostic output, adjusted in response to external stimuli. When solar radiation pressure increased, the line shifted. When the object's orientation changed relative to Earth, the radio pulses synchronized. Hale's conclusion, shared in an internal memo that later leaked, was chillingly concise. The object appears to be responding to its environment. The escalation did not stop there. 18 hours after the initial event, at 2047 UTC, a second wave of anomalies began. One of the weaker spectral lines, previously attributed to nickel isotopes, vanished entirely, not weakened, not masked, gone. Simultaneously, gravitational models detected a minute but measurable change in 3I Atlas's trajectory. Its velocity increased by 0.09 kilometers per second, without any corresponding ejection of mass or energy plume. For an object estimated to be less than a kilometer across, this implied an energy input equivalent to several terajoules, applied silently. Then came the alignment. At 3:12 UTC today, analysts noticed that the object's orientation, inferred from polarization data, had shifted to face within 0.3 degrees of Earth's orbital plane. This alignment coincided with a brief spike in Earth's magnetosphere. Satellites over the South Atlantic Anomaly reported minor sensor glitches. Radio operators in parts of South America experienced transient interference. No damage, no blackout, just enough to be noticed. Inside control rooms, the atmosphere changed. Conversations dropped to whispers. Data access tightened. Requests for comment from journalists were met with carefully worded denials. Governments did not issue statements, but they did not deny involvement either. Silence in situations like this speaks volumes.
I remember one line from an internal NASA briefing: assume non-random behavior until proven otherwise. As the hours passed, the philosophical weight of that assumption began to sink in. If 3I Atlas is capable of modulating its spectral output, adjusting its motion without reaction mass, and emitting mathematically structured signals, then we are no longer dealing with a simple interstellar visitor. We are dealing with something that operates under rules we do not yet understand, or something that follows rules by design. And yet, uncertainty remains. There is still no definitive proof of technology. No unmistakable artificial structure has been imaged. No message has been decoded. Every data point still exists in the narrow gap between extraordinary physics and extraordinary engineering. That ambiguity is what makes this moment so profound. Science advances not when answers are found, but when questions become unavoidable. As I look at the latest spectral plots, now archived and mirrored across secure servers worldwide, one thought keeps returning. For centuries, we have scanned the cosmos, assuming that anything truly artificial would announce itself loudly, through beams, signals, or unmistakable artifacts. But what if intelligence announces itself quietly, through restraint, through control, through a spectral line that shifts not because it must, but because it chooses to? Maybe we are not witnessing the beginning of an invasion or even the discovery of a machine. Maybe we are witnessing a test, a probe, or simply a phenomenon that forces us to confront the limits of our assumptions. The universe has always been under no obligation to make sense to us, but moments like this suggest it may be paying attention. As of this recording, 3I Atlas continues on its path, its spectral lines stable, for now. The radio pulses have ceased. The object is silent again. But silence, as we have learned, does not mean inactivity. It may simply mean waiting. What happens if the spectral line shifts again? What happens if the pulses resume, stronger, clearer, undeniable? And what happens if next time the alignment is not coincidental? This story is far from over. Subscribe to stay with us as the data continues to come in, because the next update could arrive at any moment. And when it does, it may finally answer the question we are only beginning to ask. When the universe speaks through physics itself, are we ready to listen?